So for these word problems, the first thing you want to do is to define your variables. On number 3, flying to Kampala with a tailwind, a plane averaged 158 kilometers per hour. On the return trip, the plane only averaged 112 kilometers per hour while flying back into the same wind. Find the speed of the wind, and the speed of the plane in the air. Once again, I just want you to write the equations. You don't actually have to find the speeds of the wind and the plane, but those are our variables. So I'm going to say P is going to be the speed of the plane, and W is the speed of the wind. So that's what P and W are going to stand for.
Do we have to know which one?
All right, so if it has tailwind, that means that the wind is going to be pushing it. They're going in the same direction, the plane and the wind. So if they're going in the same direction, what do you think you're going to do with P and W? Add them up. So P plus W is going to equal, what is the average speed when they're going in the same direction? 158. Okay, and then on the return trip, it's now going against the wind. So they're going in opposite directions. So what do you think you're going to do with P and W? So P minus W is going to equal what? 112, because when they're going back, it is 112 kilometers per hour. These are my 2 equations. 2 variables, 2 equations. You don't have to solve it.
So do all of them have 2 variables and 2 equations?
No, some have 3.
So but the minimum is
2, yeah.
okay.
All right, go down to number 5.
Oh, now this makes more sense.
You work at a fruit stand that sells apples for $2 per pound, oranges for $5 per pound, and bananas for $3 per pound. Yesterday you sold 60 pounds of fruit and made $180. You sold, because you work at the farmer's market, you sold 10 more pounds of apples and bananas. All right, first, label your variables. What are my variables in this equation?
A equals apple.
A is apples.
O equals orange.
We'll say O is oranges. I'm going to put a little line through mine so you can tell that it's not a 0.
O is banana.
And B is bananas. Why does a line through it make it look like a 0?
Because you would do that in math, I feel.
If you put a 0 and a line through it, that's the math term for none, actually. It's not a 0. No, like if you had a no solution, that would be a 0 and a line through it. But if it said what are the solutions and you put 0, you're telling me the solution is 0. Does that make sense? Okay.
Bro, but he had my mind blown.
Yeah. Okay. Anyway, so okay. What are one of my totals?
60
60. What is 60? Like a total of what?
Pounds.
All right. And the term that's representing the pounds are the A, the O, and the B, right? Because A is the number, or the pounds of apples, O is the pounds of oranges, and B is the pounds of bananas. So what do I do with them to get the total number of pounds?
A plus O plus B.
Yeah, A plus O plus B. No, because that is the money. And I'm not worried about how much it costs. I just want to know the total amount of pounds. So don't put how much it costs in there, because this is just the pounds. And the A, the O, and the B already are in pounds. So you don't need to multiply them by the money, because then you're getting a whole other thing. So this is the total number of pounds. These are representing the pounds of each fruit. All right, and so now what's my other total?
180.
180. And now this is money, and so this is where you're going to be putting in 2 times A, because it's $2 for every pound of apples, plus 5 times the O, $5 for every orange, plus $3 for every banana. Now, how many variables do I have? How many equations do I need? 3. So I'm going to need another equation. You sold 10 more pounds of apples and bananas. Normally it's this last little sentence that's going to give you that third equation. What am I comparing here?
Apples to bananas.
Apples and bananas. So I know apples is going to equal bananas in some way. That's where your equal sign's coming in, because you're comparing apples and bananas. Now I'm telling you, there are 10 more pounds of apples than bananas. So what do you have more of, apples or bananas?
Apples.
Apples. So where do you need to plus 10 to make it equal? Bananas.
Into the banana.
Because apples are already bigger, so to make it equal, plus 10 to the bananas. Now you have your 3 equations, and you're done.
Oh, so you're only supposed to do equations. You're not
Yes.
supposed to solve them.
If there was 6 variables, we'd have to put 6 equations.
We're only ever going to do 3, though, but yes. That would be crazy. Okay, I am going to help you on number 6, too, as well, because people are getting really confused on that one.
Where can I use this in real life? I mean, in real life.
All right. A boat traveled 210 miles downstream and back. The trip downstream took 10 hours. The trip back took 70 hours. What is the speed of the boat in still water, and what is the speed of the current? So, my 2 variables, I am going to use B for the speed of the boat, and I'm going to use C for the speed of the current. It's very similar to number 3, which we already did. Alright, so I have this boat, right? Here, I'm going to draw a boat.
You already drew one. Oh, this is recording.
Boat
Yeah.
speed.
Alright, so I have this boat, and it is going downstream 210. And I know you can probably read this question 2 different ways, but I think what it's talking about is it's traveling 210 downstream, and then it's going back another 210. So this whole distance is 210. Does that make sense?
It's upstream of thing.
So 210 total for both.
So going there and back would be 420.
Okay.
It's
yeah.
210 there, 210 back.
Okay, yeah, that's fine.
All right. When it's going downstream, it takes this boat. Shh. Josh, you paying attention?
105 to get there and then 105 to get back though?
No, that's what I'm saying. You could read it both ways, and I would give you credit if you read it that way.
Oh.
But this would avoid decimals. All right, Isabel, are you paying attention?
Yes, ma'am.
All right. 210. So we are going 10 hours to go downstream with the current, and it is taking us 70 hours to go upstream against the current. So what you're missing here is the speed, because if you notice on number 3, I already gave you the speed, right? How do you find speed if I give you distance and
Something
time?
over something.
Distance over time. Think about it. Miles per hour. Miles divided by hours. Distance divided by time is the speed.
I said that.
So your speed going downstream is 210 over 10. Your speed going upstream is 210 divided by 70. 3. 210 divided by 70. Yeah. All right, the rest of the paper is for you to do.
Wait, she was